Okay, right, today we are going to be looking at the equation of a line, and this is part 1. So we're going to be looking at how we can use the equation of a line, how we can graph the equation of a line, and then we'll finish with a real life problem to give it a little bit more meaning. First thing we need to look at is what is the equation of a line, or in other words, slope-intercept form. So the equation of a line is y equals mx plus c, or y equals mx plus b, depending which one you are being taught. Okay, but everything means the same. So the m is called the gradient or the slope, and the c is called the y-intercept. So that means when we graph the equation of a line, where it intersects on the line, this is what the number at the end is going to be. The gradient or the slope is important because it tells us the rate of change between two quantities, which we'll move on to in a future video. Okay, so the first thing we're going to look at is how we can graph using the equation of a line. So let's say we have the equation y equals 2x plus 1. Okay, so there's many ways to graph, and the first way I'm going to show you is how we do it using a table. This is probably the most popular way. So we have x and we have y. And what we can do is we can put some values in for x and work out what the y value would be. So for example, I'm just going to put 0, 1, 2, and 3. And if I substitute them into the equation, we just say, okay, what is 2 times 0 is 0 plus 1 is 1. If I substitute 1 in, 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. And then finally, 2 times 3 is 6 plus 1 is 7. And they're my ordered pairs. So I have 0 and 1, 1 and 3, 2 and 5, 3 and 7. So now I can go and plot them on my graph. So 1 and 0, 1, 1 and 3, 2 and 5, and then I have 3 and 7. And I can draw a straight line through them points. Another way we can do this, which will give us exactly the same answer, is we can just use the equation straight away. Okay, so if we look here, the gradient or the slope is the rate of change, which can also be represented as the rise over the run. Okay, so what that means is if I write this as a fraction, which as a fraction it's 2 over 1, it's telling me that I need to rise by 2 and I need to run by 1. What I tell my students is if it's a negative, I will run to the left. If it is a positive, I will run to the right. But depending how you've been taught, people say it differently. Okay, so what I'm going to do now then is the number at the end, which is positive 1, is the y-intercept. And I'm going to do the rise over the run. So I'm going to rise by 2, and I'm going to run to the 1. When you're graphing linear equations, you only actually need 2 points, but if I carry on repeating the process, it will generate a straight line, y equals 2x plus 1. So something that we're going to look over in future videos is looking at the slope or the gradient, which is the rate of change, which is represented by the letter m. Okay, so just some different ways of how we're going to see the gradient. So rise over run, change in y over change in x, and then this formula, which we'll look at in the future, is y2 minus y1 over x2 minus x1. This is something that we can use when we don't have graphs and we just have ordered pairs to deal with. Okay, but we're going to have a go now at graphing a negative gradient or a negative slope. Okay, I'm not going to do it using the table. I'm going to do it using the rise over the run and the y-intercept. So first I'm going to plot the y-intercept, which is going to be 0, negative 1. And then we do the rise over the run. So the slope is negative 3 over 1. So I'm going to rise by 3. 1, 2, 3. And because it's a negative, I am going to run 1 unit to the left. I could keep repeating that, but I only need 2 points to actually do a graph. And that is what my graph will look like. Okay, so that is basic how we graph equations. So you could use a table or you can do the rise over the run. Okay, let's put it into a real life concept then to finish this video. So let's say a taxi charges 2 dirham per kilometre plus 4 dirham fee. Write an equation to represent the taxi price, and then I am going to graph this equation. Okay, so the first thing I notice is that it tells me it's 2 dirham per kilometre. That is the unknown in this example. I don't know how many kilometres I'm going to be driving. So I'm going to put kilometres at the bottom for x, and then at the side I'm going to have the cost. That way I can read the kilometres and just go up to my graph and work out what my cost is going to be. Okay, so to work it out, naturally I would do 2 dirham multiplied by the number of kilometres, and then I would add the 4 dirham fee. So I'm going to represent this by saying 2 multiply the number of kilometres, and then I'm going to add the 4 dirham fee. And that is the equation of this situation. This is the equation I can use to work out how much I'm going to pay for a certain number of kilometres. So my y-intercept is 0.4. My slope is 2 over 1, which is rise over run. So I'm going to rise by 2 and run by 1. Rise by 2 and run by 1. Then I can draw the equation of this line to represent this information. Now if we actually look at this graph, we can see where the actual graph begins. This is representing the cost of just getting into the taxi, so before we've actually done any kilometres at all. And then if I want to work out the kilometres, I can either use the graph. So let's say I want to work out how much I pay for 3, it's going to be 10. Or I could just substitute in x is 3 into the equation, and my answer will give me y is 10. So for 3 kilometres, it is 10 dirham. The last thing we can do with this then is, as you can see, there's no negative numbers on this graph. I only have one part, all the positives. Why is there no negatives? Well, in this type of question, you can't have either a negative kilometres and you can't have a negative price for a taxi journey. So it'll be impossible to have a negative distance in a taxi, and it'll be impossible to pay a negative price. And that's why there's no negatives in this types of graphs. In the next video, we're going to look at how we can write the equation of a line using the slope and an ordered pair.